Greetings, my name is Andre Cerzari, and this presentation is on concepts for mobile ultrasonic test equipment. These concepts will be presented in a very simplified manner in order to facilitate discussion on each concept. The two concepts that I will be discussing will be categorized as sensor position and scanning and mobile platform concepts. For sensor positioning, I will briefly discuss linear rail, the linear array, and the planar array. First, the linear rail involves either a single transducer or a single transducer probe setup that will be placed here, and the transducer will move along a linear rail, and this can be actuated by any type of device such as a linear motor or a ball screw mechanism. Having one sensor will likely reduce the cost of having multiple transducer systems and reduce the cost of their control. This is also what's commonly found on many automated test equipment in laboratories and would be very beneficial for use in an A-scan. Next, a natural transition from the linear rail would be the linear array. The linear array uses multiple transducers along a line. Having multiple transducers will likely reduce the time required for moving the transducer in any various direction. This type of setup may require a very specific separation for a desired part. Well, this may involve prior knowledge of the part. For instance, you could either have a measurement in a pulse echo where you are measuring directly down here on a test piece and down here on a test piece, but then this gap might not be covered. So it's also possible to use an angled beam and shoot the beam at an angle, and then just clock the amount of time that it takes to come to the next sensor. If each one is sent in that direction, you can use a C-scan to see if there's any flaws in the test piece. Another concept that could be used would be a planar array, and this way more transducers could be used along the line, and this might be the most beneficial in a C-scan. And similarly, a series of linear rails could be utilized to also create a planar array. As far as mobile platform concepts, there were four that are going to be discussed. These are the suction, extended boom, cable with the normal pressure, and the common mobile robot. First, the mobile platform, which includes a suction, will typically have a suction cup either in the form of appendages, or will have suction cups and then wheels which can navigate them. The point of the suction cups is simply just to keep the mobile robot on a platform. A main disadvantage of having a suction cup would be on grainy surfaces where it's very difficult, such as sand, to attach to a surface. The main goal is to have suction be greater than the total weight of the robot's cargo, which could include many pounds and gallons of couplant and electronics. Next was the extended boom. The extended boom can be configured in many fashions. The extended boom is a long boom with either a linear or array setup. This array setup uses an external mobile platform to guide the boom, and if it needs to be turned around, it can be turned around at this location so it can measure upwards. This is a extended boom on a crane, which is just used to guide it along a surface from the top. The normal pressure robot is simply a robot which uses a cable and then uses a pneumatic or some type of actuating device to keep a pressure on the robot on any particular surface. in theory, if as long as the pressure provided by the the piston here is greater than the total weight of the robot, and the coefficient of friction here is large enough to uh, not slip on any surface, then this could be used on many different types of inclines. Lastly, a, the last concept is just to use a common robot to attach any transducer setup. For instance, this Roomba, which uses two wheels, it could have uh, a linear setup placed on the back.